today, or what are the some other solutions we have actually promoting today based on today's technology. So if you have, depending on what type of WAN transport that you have, I mean, this is probably useful for the networking guys here or the WAN guys over here, is what do you have between the two data centers? Do you have dark fiber, which is basically a fiber run between the two data centers, or you have some sort of a DWDM or an optical network between the data centers? And we have, or do you have MPLS service that the service provider provides? That's usually a subset of some of the users. And obviously, ubiquitously, everybody has IP connectivity between the data centers. And we feel that, you know, that's sort of the direction. I mean, definitely dark fiber and DWDM are used to very heavily today, but we definitely feel for longer distances. I know that I was been in the booth answering hundreds of customers. Everybody wants to move like really long distance. You probably don't have like dark fiber or like between Idaho and Phoenix or something. So I mean, you know, there's a lot of people asking.
Almost AT&T.
Yeah. So I think IP is going to be available everywhere, and as you're going to see in the next slide, you're going to spend some. Cisco's innovation is going to come into play where you can do over IP much better going forward. So we have some solutions for encryption, 802.1ae, which is a hop-by-hop encryption, and also IPsec encryption, WAS, and all those things. Now, for IP routing optimization, there are a couple of solutions. IP routing means I'm talking about what happens if VM moves, how does the traffic get to it, and whatnot. We can talk about you know, some sort of a granular routing that you can enable on the end second data center so the traffic is rerouted. Or you can use some Cisco solution like the global site selector as one of the ways to route the traffic. So one thing I want to leave before I move to Chad is this is sort of a futuristic LAN extension solution that we're looking at from Cisco, where this is our sort of an ideal goal, where you want to be able to, using IP infrastructure within two data centers, you want to be able to do on-demand layer 2 extensions. The network shouldn't have any impact that the core infrastructure that you have within the data centers. You should be able to do on-demand layer 2 extensions. And we also we don't want to do stretch the spanning tree across. We want to do sort of no spanning tree type of more robust way of scaling the network. So that's something we are looking at. And also, as I said before, policy and VM awareness. As the VM moves, for example, if you guys familiar with Nexus 1000, how it moves a profile, the policy profile within two ESX servers in the same data center. Imagine if we can do it across data centers. You know, these are some of the things we're looking at. I want to give to Chad to talk about storage.
So first thing is important. These are just, if you can't do these, this is not going to work, right? So the first thing is that all the vSphere hosts, you know, both at the primary site and secondary site, need to have read-write access to the same storage. Again, not everyone thinks about it the same way that the storage people do, right? But VMware has always used what's called a single writer model. So basically, one ESX host is writing to it at any one time, again, whether it's on VMFS or whether it's on NFS. But as part of the process, it needs to have read-write access on both sides, which means traditional storage replication, which always involves kind of like a replica that gets promoted, can't work as this core underlying mechanism. The second thing is, whatever we do can't involve impacting the steady state performance. So that means when you're not doing this option, for most of our customers, the feedback has been, well, if it involved reducing the production environment by 50%, that would be a non-starter. And that's true at the destination side as well. Most customers have given us some feedback that if it had some impact during the operation, it would be tolerable, but the preferable thing would be no impact all the time. The other thing is that it can't reduce the availability at the source of the destination, right? So again, these things all started to think about how we build solutions around this, and we'll talk about this in a second. It's got to be transparent to VMware, which means if it's a block device that terminates the SCSI traffic, it's going to have to be on the VMware HCL, right? Because it's basically going to be a target. And if it's on an NFS server, the remote and destination servers need to look like a common NFS server throughout the whole time. The third thing there is that the transparency of VMware means that the transition has got to always be within the timeout windows that exist within vSphere, right? So, and this next bullet here is a mind-bogglingly complex question, right? which is there's a whole variety of possible split brain states. So the one thing that's tricky on the storage side, you know, again, each one of us always thinks that our part is the hardest, right? So the tricky thing on the storage side is that, and by the way, I'm kidding, everyone's part is hard. The challenge on the storage side is storage is stateful, it's not stateless, right? So you have to basically manage that very carefully, because at the block level or at the file transfer level, you have to make sure that you have data integrity at all times. That's critical, obviously. But also, both from the storage side and the VMware side, you have to handle various possible split brain states. What happens if halfway through this process, you get some sort of catastrophic you know, change in network state between the two sites? What does it mean to VMHA behavior on both sides? What does it mean on the storage side? How do you make sure that it always ends up not kind of like half teleported to one place and, you know, the legs are at the other side, right? The other thing is that it's got to be able to handle sustained loss of connectivity between sites as well as resumption, because it's, you know, these corner cases have to be managed. Now, likewise, in the same way that those are just the base elements, right? There's the possibility for additional services. So one thing that we were looking at, and I want to be really crystal clear, you're going to see we're describing how you could do this with nothing fancy, right? How you could do it and how it operates, but also some opportunity to be able to do stuff above and beyond basic, right? So one idea that's very important is that we're talking about fairly large amounts of data here, right? I mean, if you wanted to move a 50 gig VM, like those VMDKs, 50 gigs in size, from one site to another, even if you use compression and deduplication techniques, all that sort of stuff, you're still talking about a ton of data, and it's going to take time to get there. But the vMotion is, the expectation of the user is that it has a similar kind of experience, right? So one idea that we've been working on is this idea of, wouldn't it be cool if the remote side could actually start to use it as if it were local before the underlying storage actually got there? So you'll kind of see that later on when we talk about it, and we'll make it pretty clear what's available and shipping now and what's coming soon. The other thing is that currently the model that most customers are looking at is, okay, if it operates on data stores, that's okay, but what we really want is we want this to always be able to operate on VM level objects, right? So that's the design goal.